Uh, good morning, students. Good morning, students. This is Mr. Mpetu here from Middleburg campus. So, I want to do a lesson on differential equations, which is chapter 6 for mathematics and 5. So let us get straight into it. So, suppose we are given a differential equation dy dx equals to 2 minus x all over 3 plus x. So we want to determine the general solution for this differential equation. So what we'll have to do is we'll have to try to separate the variables. So what do you mean by separating the variables? By separating the variables, we're simply saying that I want this 3 plus x to be attached to dx, then I want 2 minus y to be attached to dy. So to achieve that, I'll simply cross multiply. So when I cross multiply, I'm going to get 2 minus y dx, then I'll get 3 plus x dy. Then immediately after cross multiplying, I will then divide by 2 minus x into 3 plus x, both on the left hand side and also the right hand side. So as you can see that after dividing, this is what we'll get as a simplified differential equation. We'll get dx all over 3 plus x, which is equals to dy all over 2 minus y. So now let us continue from this simplified differential equation. So to get the general solution of this differential equation, I'm simply going to get the integral of the left hand side. Then I'm also going to get the integral of the right hand side. So as you can all see that on the left hand side, this integral will simply give us the ln of 3 plus x, which is equals to. So on the right hand side, I am going to get, so the integral of dy all over 2 minus y, so that is negative 1. We're simply going to get negative the ln of 2 minus y plus c. So now this solution here will become our general solution. So that is the first types of equation that we can solve. Now secondly, we can also be asked to find the particular solution. So the particular solution will mean that we are given the initial conditions. In this case, we are expected to find the particular solution of that equation given the initial conditions as x is 1, then y equals 2 to 2. So how then can we solve these types of differential equation? So again, also here, I'm going to try to separate the variables. So what I'm going to do, I'm going to cross multiply. So when I cross multiply, I will get 1 plus x exponent 4 dy, which is equals to, I'll have x cubed y multiplied by dx. So the next thing that I'm going to do, I can now say I will divide both sides by y1 plus x to the power of 4. Then also on this side, I am going to divide by y into 1 plus x exponent 4. So that now 1 plus x exponent 4 will divide into that. Then also here, I can see that y will also divide into that. So my simplified differential equation will simply be dy over y, which is equal to x cubed all over 1 plus x exponent 4 dx. So again, I'm going to do the same thing. So to continue from here, I'm still going to get the integral of the left hand side, and I'll also get the integral of the right hand side. So on the left hand side, I know that the integral of dy over y will simply give us the ln of y. So now how can we get this integral of x cubed all over 1 plus x to the power of 4? We can make use of the algebraic substitution method, wherein I can say let u be 1 plus x raised to the power of 4, so that du dx equals to 4x exponent 3, then dx equals to du all over 4x exponent 3. So what I'm going to do is I'm going to go to that equation where I see dx. I'm going to substitute dx with du all over 4x cubed. So we've said that on the left hand side, that integral will simply give us the ln of y. Then on the right hand side, I'll have the integral of x cubed over u multiplied by du divided by 4x cubed. So x cubed will take care of that x cubed. So I'm now going to remain with the ln of y, which is equals to the integral of du over u, but we still have that 4. So multiply by 1 over 4. So now this integral will now be the ln of y equals to, so on the right hand side I'm simply going to get 1 over 4 the ln of u. So you know that u, it is actually 1 plus x exponent 4 plus c. So now this is the general solution. So this is our general solution. So if this is our general solution, we are given the initial conditions, which are 1 x, then y it is positive 2. So we need to substitute these initial conditions onto this general solution so that we can find the value of c. So in other words, I'll simply say that now the ln of 2 equals to 1 over 4 the ln of 1 plus, so x is 1, so I'm going to have 1 exponent 4 then plus c. So we can nicely punch that in our calculators, because we'll now have the ln of 2 minus 1 over 4 the ln of 1 plus, so 1 to the power 4 will simply give us 1. So we are now going to have c as 0.52. So c equals to 0.52. So that is our value of c. So our particular solution of that given differential equation will now become the ln of y equals to 1 over 4 the ln of 1 plus x exponent 4 plus the value of c, which is 0.52. So this is our particular solution of that given equation. So I hope you find this video useful. So on the next example, we are going to do the second order differential equations, because what we're doing here, it is the first order differential equation. Thank you.